Hello everyone, I'm Mr. Ronald and I will be teaching you lesson 1-2 of chapter 1, which is entitled Kinds of Functions. So let us have a recap of the previous lecture. So in the previous lecture, I have introduced to you a function, describing it graphically, verbally, numerically, and algebraically. Now we are going to actually define what a function is, and aside from that, we're going to have different types of functions which will appear in your pre-calculus books for after this discussion. So from this lesson onwards. Now suppose we have a Cartesian coordinate system here. As you can see, I have already laid out the Cartesian coordinate system. Now all I have to do is to label this. This is our x-axis and this is our y-axis. And also on top, you could see somewhat of a relationship. And on the right of it, we have a table. Okay, now let's start by defining a relation. So a relation is any set of ordered pairs. When you say ordered pairs, these are pairs of x and y, meaning these are x values and y values together. So let me give you an example of an ordered set or an ordered pairs. Okay, let us have A is equal to the set of let's say xy, okay, with 1, 2, 2, -3, any random values. We have -2, 1, -3, 5, and so on and so forth. Now this set here, this set E here, defines what we call a relation. But a relation could also be something else, and that's a function. Okay, otherwise, if it's not a function, it will just only be a relation. So what is a function? Now let me start defining this by getting values for x and values for y. Let us have some values taken from the x number line. Okay, let's introduce negative, let's do thick, -2, -1, 0, 1, and 2. Now any values of x could be written for the x set as long as you like. Okay, you can choose from maybe from -10, -9, -8, -7 onwards up to +10, as long as you are comfortable. Now I chose -2 to +2 because first of all, these numbers are just limited. Actually, they're only 5. At the same time, the set, is where I am comfortable with. Okay, so let us see the relationship between your y and x given this equation. So this equation actually tells you something about the value of your y. Our independent value here would be the independent values, or the set of your domain in this case is x and these numbers. Okay, if for example, if your y is equal to, rather, if your x, because x is independent and your y depends on x, our y now will be the set of dependent values. If x is equal to -2, just plug in your x on this, okay? So that will be -2, so y is also -2, and we get -2 also on this part. Now if your x is equal to -1, our y will be equal to -1. It's -1 also, so -1. And for the rest of the values of x, now if you follow the same procedure as I've done, you will get the same values for 1 and 2. Now we have a set of independent values x, we have a set of dependent values y, and now we already defined a relation. But what we are trying to prove here is whether this relation that exists between x and y is a function or not. Now to solve that, I'm now going to use the virtual grapher. I'm going to label scales. So this is 1, 2, 3, 4, 5. I'm just choosing up to 5 units from the right, 5 units to the left from the origin, 5 units top from the origin for 5. Okay, and actually our y are not so uniform, so our y values should be something over this line here, and our y values for the lower part should be somewhere below or upper above the lines. Okay, now we have the scales, so let's label. This is 1, 1, 2, 3, 4, 5. Now I am done with the labeling of the numbers. So let us plot the points then. See, we have -2 and -2. That would be -2 and -2. So it would be somewhere here. Okay. And we have -1, -1. So it would be here. And we have the origin. And we have 1, 1. We have 2, 2. Okay. So we have defined some points which define a relation, and the question now is whether this set of points or this relation would be a function or not. So let us connect all of the points now. We'll connect all of the points. Okay. So connecting all of the points gives us a linear graph. It's a line. It's a line which is extending upwards and downwards. So let us highlight this thing. We have this graph extending in both directions, upwards and downwards. Now this one, as you can see, gives us a relation which is 1 to 1, because we only have one value for x and get a corresponding only one value for y. Now the same goes for our 1 here and here. The same goes for every points that we took and defined for our x here. Okay, we only got unique values for y. Now this one is a function. It is a function because it is 1 to 1. Okay, so we already defined a function. Now let us go to another example. Now this time, this is a second degree equation. A second degree because it has an exponent of 2 for x. Now let us use the same values for x and y. We have -2 negative 2, negative 1, 0, 1, 2. Okay, now for y is equal to, for x is equal to negative 2, just plug in the value of negative 2 to your equation. Y is equal to x squared, so that would be y is equal to negative 2 squared. That would give you 4. Now for x is equal to negative 1, the same procedure will be taken. So we have negative 1 squared. That would give you 1, and so on and so forth. Now in this case, we have 4 here. We have 1 here. If x is 0, then our y automatically is 0. And if your x is 1, your y is 1. If your x is 2, your y is 4. Labeling them now, I will label 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4, negative 5, positive 1, positive 2, positive 3, positive 4, positive 5. This is our x-axis. This would be our y-axis. Now we're going to define the relationship. This is, again, we define a relation here. There is a relation of x and y values here. Okay. Now for the first point, negative 2, 4, we have negative 2 and 4. So this would be here. We have negative 1, 1. So it would be here. We have the origin for 0, 0. And we have this point. So let us define the points here and here. And the next thing that we do is to connect all of the points. We connect all of the points. So that would give us this graph. Okay. It's a curved graph extending again in both directions, because you will have to consider the values of x and y. You can choose whatever x values you want and get whatever y values you want. Okay, let us highlight this thing here, this graph. Okay, so we have a highlighted graph here, and as you can see, for every x values, okay, we get a corresponding y value. For every x value, we get a corresponding y value. Now this is still a function. Still a function, okay? Why is it still a function? Because even though we have two values for we have the same values for any x value, as you can see here. We have, for one x value, we get another y value. For the same y value, we have another x value. So in other words, it still defines a relation. It is a relation. And this is still a function. And this is what we call many, or one to many. This is still a function, because for every For every x value, we get a corresponding y value, although our y value will not be unique for different x values. Another way to test if your graph is a function or not is to use the vertical line test. Vertical line test. The vertical line test is used to evaluate if your graph contains more than 2 points in the same vertical line that we are going to use. So in this case, we have a vertical line crossing the graph at this point only. So we only have 1 point for the vertical line. So this confirms that this graph is a function.